Today we are solving systems of inequalities. Quick review of linear inequalities if we forgot what they are. First thing, when you're graphing them, you need to determine, are you graphing in standard form or in slope-intercept form? So for standard form, you want to write the inequality as an equation, find the x and y intercepts, and for slope-intercept form, you want to solve for y. Number 2, pretend that the inequality is an equation and graph the boundary line. The boundary line is the line on the graph. Number 3, solid or dashed. So if it's going to be a solid line, then that means it's less than or equal to, or greater than or equal to. If it's a dashed line, it is just less than or just greater than. And lastly, you shade. So for shading, I always suggest picking a point on one side of the line, not a point on the line. So pick a point on one side of the line, test the point in the original inequality, and determine if it works. If it works, then you shade with the point. If it doesn't work, then you shade away from the point. And you'll see what I mean by that when we go over one of the first examples. Another quick reminder, super easy to forget, but we need to make sure we remember this. When you multiply or divide an inequality by a negative number, you have to reverse the inequality sign. Okay, number 1. So following the steps from above, we want to determine if we are graphing in slope-intercept or in standard form. And in this case, we're graphing in slope-intercept. Our inequality is y is greater than x minus 2. Step 2 says to pretend the inequality is an equation. So we just do that for ease of graphing. It doesn't really help us do anything other than plot the points on the graph. So if this is in slope-intercept form, we need to look at our y-intercept. That's at -2. Plot a point. Our slope is the number in front of our x value. In this case, it's a number 1. That tells us to go up 1 over 1, up 1 over 1. That's our slope. For step 3, once we pretend that the inequality is an equation and we graph the points, we need to determine if we have a solid or dashed line, and that is determined by this right here. It is just greater than, so that indicates the line is going to be a dashed line. And now that we're on to step 4, we have to determine which side of the line to shade. So I like to pick a point, any point. For this one, let's pick 0, 0. It's a line that's not, it's a point that's not on the line. And we're going to test 0, 0 in the original function. I should say the original inequality. That means I substitute 0 in for y, and I substitute 0 in for x. Simplify this. Is 0 greater than -2? Yes, 0 is a larger number than -2. That means we shade the side of the line that includes 0, 0. The second example is in standard form. We have -2x plus 4y is less than or equal to 12. So following the steps above, the first step is to determine if we're graphing in slope-intercept or standard form. In this case, we're going to be graphing in standard form. You could solve for y if you want to, but I'm going to leave it in standard form because that's where it is currently. It's already in that form. So I'm going to write this as -2x plus 4y is equal to 12. To find the x-intercept, I set y equal to 0. and I solve for x. This becomes negative 2x plus 4 times 0 is equal to 12. 4 times 0 is 0, leaving us with negative 2x equals 12. Divide both sides by negative 2. And x is equal to negative 6. That means our x-intercept is at negative 6, 0. For the y-intercept, you set x equal to 0. When you set x equal to 0, you have negative 2 times 0 plus 4 times y equals 12. Negative 2 times 0 is 0. 4y equals 12. Divide both sides by 4, and y equals 3. Your y-intercept is at 0, 3. Okay, I'm going to plot these 2 points, a point at negative 6, 0, and a point at 0, 3. This is going to be a solid line because the inequality is less than or equal to. Draw a line through those 2 points. And the last step, step 4, is to pick a point, test it in the original inequality, and determine if it's true. This time I'm going to pick 1, 1. If I test 1, 1, I have negative 2 times 1 plus 4 times 1 is less than or equal to 12. Negative 2 plus 4 is less than or equal to 12, or 2 is less than or equal to 12. That is true. 2 is less than 12, so I'm going to shade with that point that I picked. Next, we're going to work on writing an inequality. Our inequality, or our statement, says that Mr. Dempsey is selling NKHS water bottles and t-shirts to raise money for the football team. He is selling the water bottles for $2 and the t-shirts for $5. His goal is to make at least $500. Write an inequality to represent the situation. So highlight your important info. He's selling water bottles for $2. He's selling t-shirts for $5, and he wants to make at least $500. We're going to start by defining our variables, and I'm going to use x representing water bottles, actually number of water bottles, and y representing the number of t-shirts. So we know that water bottles cost $2, so 2 times x, or 2 times the number of water bottles, plus 5 times y, or 5 times the number of t-shirts. And he wants to make at least $500, could be over $500. So we're going to use greater than or equal to 500. That means this side of the inequality could come out to 500 or more, because we want it to be either equal to 500 or greater than 500. And that's your final inequality. Writing inequalities shouldn't be too challenging. Just make sure you slowly read and look for all the math information. Okay. So systems of linear inequalities. Systems of linear inequalities is when you have multiple inequalities in the equation or in the problem. So to graph a system of linear inequalities, you do the following for each inequality in the system. And what I listed right here are the steps from the front. I just typed them out for you. So you graph each line, you shade on the correct side of the line, determine if you have a dashed or solid line. And then the graph of the system is the region common to all of the half planes. So I suggest using colored pencils, and you look for the region that's been shaded with every color. For the first one, we have y is less than 2x minus 3. So I'm going to go a little faster on my graphing here. The first one's in slope-intercept form. I'm going to go down to -3, plot a point for my y-intercept. My slope is rise over run, and it's 2 over 1, so up 2 over 1, up 2 over 1. This inequality sign indicates that it's going to be a dashed line in the coordinate plane. And pick a point to test. I'm going to test 0, 0. Zero is not less than -3. 0 is actually greater than -3. So for the first time, this one does not work. So you shade away from the point. You shade on the opposite side. Number 2 is, I should say the second equation is in standard form. So to find the x-intercept, you set y equal to 0. That's going to give us 2x equals 2, or x equals 1. 1 comma 0 is our point. And for the y-intercept, we set x equal to 0, giving us y equals 2, or having a point at 0, 2. So I'm going to graph those points at 1, 0, and at 0, 2. This is also a dashed line because of the inequality sign. Oops. All right, we're going to pick a point and we're going to test that point. I'm going to pick 0, 0 again, and this time I'm testing it in the second inequality. Two is not greater than 0. Sorry, 0 is not greater than 2. I said that backwards. So 0 is not greater than 2. Therefore, that is not true. So we shade away from the point that we tested. The solution to our system is the overlapping shaded region. The overlapping shaded region is in here. It's where I have blue and yellow, which would make green. So I'm actually going to erase all this and just shade the correct solution. And you can go back in my video and make sure that I shaded the correct one, but it's just in this area here. So when you have multiple lines, you shade only the overlapping section as your final answer. All right, for number 2, I'm going to go even faster. I'm not going to talk through graphing the lines. I'm just going to graph them, and then I'll talk through the solution. Okay, now that I have all of my lines graphed, I'm just going to label them quickly. This was my first line. This was my second line. And if you notice, I did all my work in my head. I didn't write anything down. You are welcome to do that as well. All right, so we need to test points. I'm gonna pick 0, 0 for all of them. And again, I'm not even gonna talk through this. If you just watch for a second, I'm gonna shade everything and then I'll talk about the solution again. All right, so where I am highlighting in green is the final solution. So that green highlighted area is where all three colors, the blue for equation 1, the pink for equation 2, and the orange for equation 3, that's where they all overlap. So our final answer is just this shaded region here. So what does the solution of a system of inequalities represent? The solution of a linear inequality is the ordered pair that is a solution to all inequalities in the system. The graph of the linear inequality is the graph of all solutions in the system. So if we zoom in on this example here, you can see I only listed or I only labeled the shaded region. That means if you want to find a solution to the system, you can pick any point in the shaded region. So for example, I just highlighted the point 2, 3. 2, 3 would be a solution to all the systems in this equation. If I picked this point right here at 0, 3, that would be a solution. If I picked a point right here at 2, 1, that would be a solution. Any point in the shaded region is a solution to the system. And that's why you want just the overlapping shaded region. So the last set of examples is when you're given a graph of a system of linear inequalities and you need to write the system. So the first thing that I usually do is I label my lines as number 1 and number 2, so when I look back in my notes, I can clearly see which ones I'm referring to. So I'm going to label number 1, this line here, and I'm going to label number 2, this line here. If I could make a suggestion for writing, I would say to identify the slope and the y-intercept and write your equation in slope-intercept form. Okay, so let's start at number 1. So for line number 1, we need to identify the slope and the y-intercept. So right here, I can see that the y-intercept occurs at -3. Actually, I'm going to erase that and I'm going to write it as b, because that's what it is in the equation. So I'm going to write b equals -3. And then for the slope, we need to identify on the graph the rise over run. And I would do this just by counting. You could algebraically calculate it, but I think I would just look at this. I'd identify the next whole number point on this solid line, which would be right here, and I would count up. So I'm going up 1, 2, 3, 4, 5, and then I would count over 1, 2. So my slope is 5/2. And once I have these two items, my value of m and my value of b, I can clearly write my equation in slope-intercept form. So in this example, y is equal to 5 over 2 times x minus 3. Now here's one thing to pay attention to. We are actually writing inequalities, not equations. So we need to replace our equal sign with the correct inequality. What I typically tell students to do is, and you can usually do this in your head, but I'm going to write it out for now. I tell them to pick a point in the shaded region, and then you make the inequality true. So we're looking to find this right here. We want to know what is the inequality. So we have y is either greater than or less than or, whatever. But we need to find whatever that sign is. So my suggestion would be to pick a point, and I'm going to write this out. All right, so if we're picking 0, 0, like I wrote, that means I'm going to substitute 0 in for y. I'm still looking for the sign, and then I have 5 over 2 times 0 minus 3. So again, we have 0, a sign, looking for that. This cancels to 0, and then negative 3. We are trying to make this true. So what sign would we use to indicate that 0, or what the relationship between 0 and negative 3 is? We're going to have to use the fact that 0 is greater than or equal to negative 3. And the reason why we use the greater than or equal to sign is because it's a solid line in the coordinate plane. So you also have to take that into consideration. So this final line for line number 1 is going to be, or the final inequality, I should say, y is greater than or equal to 5 over 2 times x minus 3. Okay, next let's look at line number 2. So line 2 is this dashed line here. I'm going to indicate that the slope is right here at positive 1. I'm sorry, the y-intercept is right here at positive 1. And that the slope is rise 1, go over 1 to this point. We can check it in the other direction too. I can see that there's a whole number point here. So that means we go down 1 over 2. So our slope is 1 over 2. All right, from this information that we just found, we can write the equation, not the inequality. We could write the equation as y equals 1/2 x plus 1. And then we need to find the inequality. So we're looking for this sign. I'm going to pick 0, 0 again because 0, 0 is still in that shaded region. You can pick any point in the shaded region to make it true. So we're going to test 0, 0. We have 0 is some relation to 1/2 times 0 plus 1. 1/2 times 0 will cancel. We have 0 is what relationship to positive 1. And we know that 0 has to be less than 1. The reason why we do just less than is because it's a dashed line in the coordinate plane. So I can write my final line as y is less than 1/2 x plus 1. All right, and when you write your final solution for these, or final system of inequalities for these, you should write them listed together. That's the correct way. So just to zoom out for a second and zoom over to the last problem. this right here is what a system looks like. It's three systems or three inequalities listed together. So let's do the same thing for the one we just wrote. We're just going to take the two inequalities we wrote. We're going to list them as two directly in a list. Y is greater than or equal to 5 over 2, x minus 3, and y is less than 1/2 x plus 1. And this is going to be how we write our final answer. Okay, so go ahead and finish the on your own section by yourself. The answers are posted on my note sheet on my website, so you can check those out. And email me or let me know if you have any questions.